Hey, hi, this is Kunal, and today we are going to discuss about the EDA in details with one of the case study called Lending Club case study. Uh, so here, let's understand the business objective or the problem. So, what is the problem is that if you work for a consumer finance company which specialize in lending various type of loans to urban customer, where the company receive a loan applicant, the company has to make a decision for loan approval based on the applicant's profile. So there are two type of risks are associated with the bank decision. If the applicant is likely to repay, then the not approving the loan result in the loss of business to the company. And if applicant is not likely to repay the loan, then he or she is likely to default. Then approving the loan may lead to a financial loss for the company. So the objective of this is easier to understand how consumer attributes and the loan attributes influence the tendency of default. Okay, so but there is some constraint associated with the this data. So when a person applies for a loan, there are two type of decision could be taken by the company. One is loan accepted. If the company approve the loans, there are three possible scenario. So it could be either loan could be accepted or loan could be rejected. If the company had rejected the loan because the candidate doesn't meet the requirement, uh, then the company has a no transactional history of the applicant whose loan was rejected, and we will not considering that this data as a part of analysis. Once the loan is accepted, so there are three scenario that is possible. One is the applicant has fully paid the loan, and other is that the applicant is in the current process of paying the loan, and either the payment has not done fully or he has not uh, being a defaulted. Other is a charge off. We can also say that the defaulted applicant has not paid the installment in due time for long period of time, and he has defaulted on the loan. So for our considerations, since if we are talking about either he the fully paid or charge off, so we are not considering the data which is having the current, because the loan is still into the process of paying and it doesn't decide whether the applicant is fully paid or charged off. So let's go through the EDA we have performed, and we'll go in a step by step, and each of the topic in very details. So first part of EDA is that import the necessary library that we are going to use. So we have imported numpy, we also imported panda, we have imported matplot for plotting the chart and diagram. We also plotted a seaborn for the chart and diagrams, and dead times. Warning that filter one we are using to ignore the warning, and here we are loading the data into the data frame. So once we have loaded the data into the data frame, the first part is that uh, we can say the data summary or data cleaning. So here we are checking the summary of data as a part of data cleaning itself, and here we are checking that is there any do we have any header or footer or row, or any row that contain the information about the summary or subdetail or subtotal things. If there is any such kind of rows present, we need to delete it, because that rows are not going to part of our analysis. So there is a way to do that. So first of all, we are trying to see using the head part. So is there any uh, uh, summary row present or not, and we are also trying to have an idea of what kind of data we are having, and we are also checking with the test that any footer rows present or not. So here, as a part of our analysis, there is no any summary row or total subtotal rows present, and there is no footer row present as well. So let's check for some other part. of the analysis. Now let's check the shape of the data. So here it will give the number of rows and number of columns. So we are having 39,707 rows and number of column is 111. So let's check what are the different kind of loan status are values having. So here we are seeing that it is having a three kind of values: fully paid, charge off, and current. So as we already discussed earlier, we will be only considering the data which is having the fully paid and charge off, because current, as a part of current, the applicant is still paying the loan, and that will not make any that will not help to make a decision whether the applicant has fully paid or charge off. So we'll remove the data for which a loan status is current. So here we are just dropping those row, and we have seen that around 2.8% rows has been deleted. So total number of rows that we have deleted is okay, so it's at 2.87%. And we are checking do we have any duplicate row or not. So here we don't have any duplicate rows. And so once deal with the rows deletion, now we are checking do we have any unnecessary column or not. So once let's check the shape again. So we are having 38,577 number of rows and 111 number of columns. So here we are checking whether we are trying to see if there's any column are having how many of the rows as a NA or null. So we can see that we have many a column which is having 100% of the rows as a null value. Since for the column which all the rows are null value, we need to delete it, as it will not contribute in performing analysis. So there are around 55 columns we have for which all the rows values are null. So we are trying to drop here and so we are trying to drop NA all the column which is having all the rows as a null. So here axis 1 means it will delete the column. If it is axis rows, it will if axis is equal to 0, it will delete the particular row. But if it is axis is equal to 1, it will delete the particular column. And how? If all the values are NA. So after that, since we had a 111 column, after deleting the column which all the rows are null, now we are left with the 56 columns. So now we are trying to see if there is a column which is unique in nature. I mean, they are having all the values are unique. So we have a three columns: ID, member ID, and URL, which all the values are unique. Since all the values are unique, so it will not make any sense in performing the EDA analysis. So we'll delete all those. Here we are deleting member ID and URL, and for keeping the ID for the future purpose, if we need, we can delete it. So this is the syntax. We are deleting two columns. Axis 1, it means it will always delete the column. If it is axis is equal to 0, it will delete the corresponding rows. In place true means it will delete from the same data frame. So now we are left with a 54 column. We are trying to see if there is any column which is having the text or descriptions. So if is there, we have to delete it, because text and description doesn't make any sense in EDA analysis. So we have to drop them as well. So we have found that we have a description and we have a title that is a textual informations, and that doesn't make any sense. And though here we are trying to delete subgrid because our analysis we are limiting our analysis to the group level only, so we are not going to the subgrade of the loan type. And there are some behavioral data we have, and those behavioral data will be not captured while applicant is submitting the loan applications. This behavioral data is captured only if the loan is getting approved. So for the particular applicant, these details will not be there, and these details is not going to help in EDA analysis. So we have to delete those column as well. And yeah, so we will delete the behavioral data, and then after that there's, and we also try to see if we have to see the uniqueness like we have to figure out any column which is having the single value in all those rows. So if it is having the single value in all the rows, it will also not help to it will not help to it will not take doesn't make any differences in EDA analysis, because it is the same for all the rows. So we have to delete this unique value if the number of unique values is 1 for every column. And 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. So we are having such kind of 8 column which values is unique and it's a single value. And then so now we are limited with the 22 columns after deleting all those. And the other analysis we are doing is that we are trying to see if the column which is having more than 15% of the value is null. I mean, for 50% of the rows are having null value. So there are two field, month since last decline and month since last record, which is having more than 50% of the rows as a null. And since most of the data are null, keeping those will not help in EDA analysis, and we have to remove those columns. And we have also figured out there is an implied title which is a textual information. We also need to delete it. So once we have the data cleaning part, we have deleted the data. Now we have to see if data are in a standard format or not. So here we can say that term are object, interest rate are object, and loan amount into int and funded amount into the int. So these data should be converted into the, if we see the nature of the data, it should be come as a float, and term and interest should also come as a float. Installment could be maybe a string or integer value, so basically it's a 36, or grade, this could be an object. Employment length, that should be a maybe a integer value. Home ownership could be the object, that's fine. Annual increment should be float. So we are seeing that there are some of the data still that need to transform into the standard format, and so we have to see one by one what are the different kind of value we have. So if we check for the term, so term value count is equal to 36 and month. So here if it is an object, but term should be 36. So we have to see we are seeing that there is a string part, a string things has been concatenated with the integer part. So here we have to remove the string part and convert into the int type. So now data type is int, and we can see that here it has been transformed to the proper format. And then after that we have to check for int rate. So int rate are having percentage data as a string, so we have to remove that percentage part and convert into the float. So here if you check it, here we are taking each of the data and removing the percentage part, and then we are having interest rate, and this information has been changed. Now some of the value we have identified as a int, and that need to be converted into the float. So here we are converting, and we can see that the loan amount, funded amount, here they are coming as a float. Let's see the grade. Here grade we have A, B, C, D, E. and employment length, that should be as a numeric value, but here see that it is also having the string concatenated value, so we have to remove that string part. And since if we check about the some numeric part, like a loan amount, funded amount, we are limiting to the 2 decimal point. So once that done, so we have a issue date. Issue date, if we check it here, what is the format of issue date? Loan amount ID. So it is coming at December 11, so it's not in very good format, so we have to convert into the date format, and then we are converting it here into datetime format. So why we are converting it to the datetime format? Because it help us into give into the year, date and month, and we can easily derive the, if we need to derive the year or month, we can easily derive the new variable from this one. Now we are checking, is there any column have a null field or not, and we're checking into the percentage. So one of the employee length is having 2.6%, and public bankruptcy, PUB rec bankruptcies, they're having 1.8% of the data as a null. So overall we see that around less than around what we call as a 5%. So instead of imputing, we are dropping that rows. Since if it is a less than 5%, we can drop that, but if it is a higher than 5%, then we have to impute it based on the type of data. Now we can see that 4.48% of the data has been dropped, and that is not too much data, so but we can easily drop it. And now we are still seeing that is there any data is having, or any column is having the n value or not, and here we don't see any n value. So now we can go for further analysis, and here employment length we are having, this is the function we have written for removing the string part from the employment length, and now that has been removed. After that, we are trying to derive some of the column that can help us for further analysis. So from issue year, from the issue date, we are deriving issue year and issue month, and here we can say that okay, and this is low. So now we are good with our data. Now we can start performing the EDA part. So we will start with the univariate analysis, and here we have done the data dictionary, field name with the proper naming, and now we are trying to bucket the value in different buckets. So we have some range from 0 to a. So if we see here, bucketing the loan amount into different buckets. So if it is less than 5,000, we are putting at 0 to 5k. If it is 5 to 10, then 5k to 10k, and yeah, so 10 to 15, 10 to 15k. So why we are bucketing here? Because it is a continuous value, and if we try to draw the diagram, so it will just give some kind of distribution, but we will not understand what are the different ranges we have. So we are trying to convert into the kind of categorical data, and it is a kind of order categorical data, and bucketing it. So same things we are doing for annual income, interest rate. We are trying to put interest rate into different ranges, and we are bucketing the data. And DTI, debt to income ratio, so less than 8 is a very low, greater than 8 and 12 low, 12 to 16 moderate, high, and very high. And this is the function we have written. It will draw the two diagram. One is called distribution plot and box plot. So now we can see that here I'm trying to plot the box plot to see that what is the ranges of data we have, and is there any outlier present or not. So you can see that there is just some outlier present into the loan amount, funded amount, and funded amount investment. So this, if you see it here, this is a similar kind of outlier we have for each of the variable or attribute. And okay, so here annual income, we are also having some of the outliers here, and this is for interest rate, so we are having some outlier. And for DTI we don't have any outlier here, and this is for installment. Still we can see that. So now what we are trying to do, we are trying to remove the outlier, and we have written some function. We are using the method of interquartile ratio, interquartile mechanism to remove the outliers. So here we have used this function, and for one factor we are putting 1.5, somewhere we are also putting the 1. We can tune it. So based on the things, sometimes we can tune the threshold. So basically we keep it as around the 1.5 and between it's around 1.5 we keep it. So but we can increase or decrease it to fit the our requirement. So after that we can see that we have removed a lot of outliers. So we should not be deleting all the data, but we have, based on the business understanding, we have to remove the data outliers. A lot of outliers has been removed. It's annual income and installment. And then now these are done. These are the field we have done for numeric value. So here we have draw the diagram, box diagram for numeric value, and this is we are drawing the plot diagram after removing that. So here it will draw for distributions, and we are also trying to so this is called bar plot. So we can see that ranges of the data, what could be the mean, what could be the standard deviations, and what could be the minimum value, what is the so majority of the data generally it contains between 25 to 75%. This is what we can see that. So 25% to is around 5,000, and between to 30,000, around 40,000. So majority of the data coming from the 5,000 to 30,000, that we can see it here, and mean is around 9,800, and there won't be some outliers also. Most of the means right. So here we can what is the information we can what is the inferences we can drive that there are multiple information we can derive from here. One is called what is the mean value, how the data is distributed across centered around the mean, and what could be the maximum value, what could be the mean value, and 25% of data and 75% of the data. Same things we can see it here. I say around a kind of normal distribution. So most of the it should be here 55,000, and this is the bar plot. So either bar plot or the histogram, you can get the similar kind of data. So so you can see that most of the data is coming from 25% to 75% of the data. Similar things we can do it from the funded amount, interest rate. These are for numeric value. Now we have a categorical. So generally we draw the histogram and box plot for numeric data. For analyzing the categorical data, there are two kind of categorical data: unordered and ordered. So we draw the bar diagram. Okay. So here we can see that if we talk about the home ownership, so we can see that the person who is living on the rent are the highest number of the people, and then followed by mortgage, and the very less number of the people on the house. I mean, majority of the application are either living on the rent or mortgage. So these are the information we have tried from the home ownership. Similar information we can try for, so majority of the loan either we are. So these are for the purpose. So here we can see that the majority of the people who have applied for the loan are for debt consolidations, and then the majority of the people who had applied for the loan are coming from CA. and this is the order categorical variable. So in order categorical variable, employment length, so who is having around 10 years, are the majority of the applicants are having the 10 plus year of employment rate. Then coming for bivariant analysis. So bivariant analysis, what we do, generally if you check, see that, so one is a loan status. Here loan status is our target variable, and annual income is our predictive, or we can say that independent variable. We are trying to establish the relations, and here we are in loan status, we are only interested into the knowing the charge of. So we are not considering about the fully funded details. So we are only interested in what are the factors that are affecting the charge of or loan defaulted. So we are trying to see for the applicant uh, who has been defaulted uh, with the we can say that with the independent variable. So here it's the annual income. We can say that with respect to the charge of procession. Let's try to see some diagram here. So if we see that annual income versus charge of, so here could be the charge of operation, here it could be the annual income. So we can say that the people who are having 0 to 40k of annual income are highly number of charge of, and who is having 80k to above, I mean they are likely to have a very less number of defaulted. So it means that if the annual income is increasing, the charge of profession is decreasing. Interest rates was a charge of. So if we say that very high interest is also causing the charge of proportion. And then home ownership. So the people who own the house are having very less chances of being defaulted. And then purpose versus charge. So we can say that the people who has taken the loan for a small business are defaulted to the are being defaulted. Most of the people who has, so majority of the people are from the a small business who has taken the loan, and they have leading they have that is causing the charge of proportions. Debt to income, if debt to income ratio is low, I mean the lower chances of having the lower chances are having the if it is a high chances of defaulting. Bankruptcy record versus charge off. So if high number of bankruptcy records in public, this means that this person going to be defaulted. Issue, we can see that 2007 was having high number of defaulted records. We have to understand why 2007 was having, maybe because that we have to figure out. And then issue month, so basically if you check it here from May to October, majority of the defaulted has been happened. And then estate versus charge up. So if you check it here, we are having TN is a estate who most of the people are coming from defaulted. And grade, so G grade is having high number of defaulted, and A is having low number of defaulted. So correlation matrix, why we go for correlation matrix? To understand the relationship between the independent and the target variable. So here target variable is our what we call as a loan status. So I think we have the loan status. Here we have removed the loan status, and we are trying to see the different correlation among the independent variable. So we can see that installment, funded amount, loan amount, and funded amount, these are very highly correlated to each other. It means that the most of the variable has been derived from each others only. So we can drop some of the that variable, because it will not add any a value to perform the analysis. And there is a idea and issue that is also highly correlated. We can drop one another term and interest rate. Here we can say that. So we have dropped the installment ID, issue year, issue month, and then we are again performing. So we can see that funded amount, LN amount, and funded amount are having highly correlated with each other. Negative. So these are the inferences we have figured it out. So negative correlations, loan amount has a negative correlation with the public. If you check it here, loan amount is having the, so here we can say that there are some of the negative correlations. We are also having here the negative correlation with the bankruptcy, and it's with the funded amount, loan amount, funding amount, and we are also having, yeah, the term has a strong connection with the loan amount. If you go with the term and loan amount, so loan amount, so 0.36. These are the inferences we can derive from that, and this is with respect to the terms. So if we check it here, if term is increasing, then loan amount is also increasing. So if we see the term amount, we are having the loan amount around less than 50,000, but here if the term has been increased, loan amount has been also increased, and interest rate has been also increased. So these are the EDA we have performed for our lending club case study. And for this part, and if we are going to do some more into the, if you are going to build some machine learning algorithm, there are some additional task we need to perform, that is called converting the categorical variable into the numerical value, or getting the dummies, and then also we have to scale the data using the min-max scalar or standard scalar. So that we'll be discussing into the when we are building the machine learning algorithm. But for today part, that's it. And if you have liked my video, please like and share it. Thank you.